Okay, so the next concept is the concept of Q factor. Q, by the way, stands for quality factor. I don't know why. Okay, I don't know why this Q is the quality of it, right? But you got to understand, the bigger Q is, the less damping you have. So big Q equals less damping. It is roughly how many cycles it'll go before it stops. So this Q is, I took interactive physics and I programmed in the differential equations for the Q factor, okay? And then just made a simulation where you can type in a Q factor and see what it does, right? This is a Q factor of 10, approximately, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. Is it 9? Is it 10? I think you could argue that it's 9 as well. I mean, I just don't know, right? Remember, it's roughly how many cycles it goes before it stops, right? This is a smaller Q. So a small Q is more damping. You can see that it only goes 5 times roughly before it stops. 1, 2, 3, 4, 5. Okay? So that's the most important thing. This is by the way, it's just an arbitrary unitless number, kind of like the Reynolds number we did in fluid mechanics. Okay, so this is an engineering thing. This is from the engineering subtopic. Okay, let's look at critical damping. Okay, critical damping is, the notion of critical damping is that it reaches equilibrium in the shortest time. Okay, reaches equilibrium in the shortest time. So this one right here is our critically damped one. Notice that the Q factor is 0.5, and it reaches that equilibrium in about 1 cycle. Our period here is 2 seconds. Okay, and in about 1 cycle, it just, whoop, there it is, right? There it is. Notice it doesn't overshoot. And it doesn't take a long time, right? So this one is over damped. This is a Q is equal to 0.25, right? I made it even smaller, right? And notice at 2 seconds, it's pretty far from equilibrium, right? It's like, whoa, at 1 cycle, it hasn't even made it there, right? It's taking like 2 cycles to do that, which makes sense, right? It's half the Q factor, okay? And so this guy's over damped. So this is taking too long, takes too long. That's why it's not critically damped, right? You look at that, right? This guy reaches the equilibrium pretty fast, but it overshoots, right? So this is a Q. Q is 0.75, okay? It reaches equilibrium pretty quickly, but it overshoots. So this one overshoots, so therefore it's not critically damped, okay? So if they ask you to draw a critically damped curve, make sure it doesn't overshoot equilibrium. It just, woo. Okay? And this is underdamped. Okay, notice it overshoots a whole bunch of times, right? And I put a Q of 2 in there for that. Okay, so critically damped gets to equilibrium in the shortest time. It doesn't overshoot. Takes about one cycle. All right.